When people talk about life beyond Earth, most of the time it stays in the realm of abstract distance. Other galaxies, other star systems, places so far away that the idea of life there feels almost symbolic instead of real. But Kepler-452b changed that feeling. Because for the first time, scientists weren't just talking about a random distant world. They were talking about something that looked strangely familiar.
An amazing discovery by NASA to tell you about. The space agency says it has found what it's calling Earth's cousin, the most similar planet to our own they've ever found.
A planet often called Earth's cousin. Kepler-452b orbits a star very similar to our Sun. Not a red dwarf, not some unstable giant. A calm, middle-aged G-type star. The kind we understand. The kind Earth itself revolves around. That alone made it special the day it was confirmed. But what really set it apart was its position. It sits inside its star's habitable zone, the region where temperatures could allow liquid water to exist on the surface. And in astrobiology, liquid water changes everything. Now, nobody has seen oceans on Kepler-452b. Nobody has photographed continents. Everything we know comes from light curves, star dimming, and subtle wobbles. But even within those limits, the data has led to some very interesting questions. The biggest one, could life exist there? Or more specifically, could it have existed for a long time? Because Kepler-452b isn't just in the habitable zone. It's been there for an unusually long time. Its star is older than the Sun, and that means Kepler-452b has had a longer, more stable window for life to develop.
As NBC's Peter Alexander reports, it's generating a lot of excitement about the possibility of life far, far away.
It makes me feel like there really is a solar system like our solar system out there. There really is another Earth out there.
On Earth, it took about 1 billion years for life to begin making significant changes to the planet's atmosphere. On Kepler-452b, that process could have started much earlier, with more time to evolve, diversify, and potentially become complex. This timeline is what makes scientists pay attention. If life emerged there under similar conditions, it would have had more time than life on Earth to progress. Maybe simple microbes, maybe ecosystems, maybe something we don't even have language for. Now here's where the new discoveries come in. Over the last few years, astronomy hasn't just improved in terms of telescopes. It's improved in how we interpret data. New models, better simulations, and more refined algorithms have allowed researchers to revisit planets like Kepler-452b with more sophistication. These new analyses don't confirm life, but they do refine the conditions. Researchers have taken a closer look at the type of star Kepler-452b orbits. It's slightly brighter and more luminous than the Sun, which means that while the planet sits in the habitable zone now, it may not always have been in the exact same thermal sweet spot. This matters, because habitability is not a static thing. Planets drift, stars evolve, radiation changes. A world that is habitable today might have been frozen in the past, or could be scorching in the future. But models suggest that Kepler-452b has likely had stable conditions for billions of years. Not perfect conditions, but stable enough. Another big update involves its size and gravity. Kepler-452b is about 60% larger in diameter than Earth, which suggests its gravity is stronger. That has two major implications. First, a stronger gravity could help it hold on to an atmosphere more effectively. On Earth, our magnetic field protects us from solar wind stripping away our air. But even without a perfect magnetic shield, a planet with more gravity can resist atmospheric loss better than a smaller world like Mars. Second, higher gravity affects how life would function physically. If life exists on Kepler-452b, it might be adapted to stronger gravitational forces. Taller structures would be harder to evolve. Organisms, if complex, might be stockier, more grounded, more compact. But even that is speculative. The real excitement comes from what might be in its atmosphere. Scientists haven't directly measured Kepler-452b's atmospheric composition yet. It's too far and too faint for our current direct imaging techniques. But they've developed increasingly precise models for what its atmosphere could be like based on its mass, temperature, and star type. Some models suggest it could be similar to early Earth, rich in carbon dioxide, warmer, more humid, a greenhouse world, but not an extreme one like Venus. Others suggest it could be more like a super-Earth with thicker clouds, higher pressure, and a denser atmospheric envelope. And that's where things get interesting. Because thick clouds don't just trap heat. They also protect surfaces from radiation. Which means if Kepler-452b has a dense atmosphere and cloud cover, its surface might actually be less exposed to stellar radiation than Earth is. That makes it more protective for potential life. On Earth, life didn't just survive radiation, it adapted to it. It used it, but it also suffered mass extinctions from it. A planet with natural atmospheric shielding could create a more stable evolutionary environment. Longer stability, fewer resets, more continuous development. That's not proof of life, but it's a very interesting set of conditions. There's also the question of geology. Kepler-452b's size suggests it could have tectonic activity, possibly even more vigorous than Earth's. And tectonics are crucial. They recycle nutrients. They regulate carbon dioxide. They help stabilize climate over geological timescales. Without plate tectonics, Earth might have ended up like Venus, hot, dense, stagnant. If Kepler-452b has active geology, then it has one of the key ingredients for long-term habitability. Then there's water. This is the big mystery. We don't know if Kepler-452b has liquid water on its surface because we can't see it directly. But based on its orbit and the energy it receives from its star, it's highly plausible. It could be an ocean world. It could have shallow seas. It could have large continents. It could even be a world covered in global haze with hidden liquid layers below. All of those scenarios are physically possible, and each of them supports some form of life differently. Ocean worlds might support microbial ecosystems similar to Earth's early oceans. Continental worlds could develop land-based life. Haze or cloud-covered worlds could host life in upper atmospheric layers, like some scientists speculate could happen on Venus. The point isn't that life definitely exists there. The point is that in terms of astrophysical conditions, Kepler-452b checks more boxes than almost any other planet we've discovered so far. But the most important new discovery isn't about the planet itself. It's about how we are learning to detect life. Future telescopes, like the next generation of space observatories and large ground-based arrays, are being built specifically to analyze the atmospheres of distant exoplanets, not just for temperature or composition, but for biosignatures, chemical signs that on Earth are strongly associated with life. Things like oxygen, methane, ozone, gas combinations that shouldn't coexist unless something is constantly producing them. If in the future we observe Kepler-452b's atmosphere and find a mix of gases that's wildly out of equilibrium, that would be one of the strongest hints of biological activity we've ever seen. Not proof, but a serious clue, because chemistry lies when physics forces it to, but biology lies all the time, and it leaves fingerprints. Right now, Kepler-452b remains a candidate, a possibility, a world filled with potential but still wrapped in distance and uncertainty. But what makes it different from countless other exoplanets is that it isn't extreme. It's not a world of liquid lava, not a gas giant impossible to land on, not a frozen rogue planet in darkness. It sits in that narrow, quiet zone where complex systems can develop, where seasons might exist, where climates could form, where evolution could play out over billions of years. And whether or not life exists there, Kepler-452b has already changed how we think about life in the universe. Because it showed us that Earth isn't a rare anomaly in terms of basic conditions, that stars like our Sun are common, that planets like ours are not cosmic accidents. They're part of a pattern. And if the pattern repeats enough times, at some point life doesn't feel like a miracle. It starts to feel like chemistry with time. Kepler-452b sits out there, almost 1,400 light-years away. Too far to reach, too distant to photograph in detail, but close enough, in cosmic terms, to study, to model, to imagine, not as fantasy, but as a real place, a real world orbiting a real star, with real physical conditions that could support life.